Good morning, everyone. So in the previous lecture, we have already discussed how to show continuity and discontinuity. Okay. So here now we are starting exercise 6, and here I have taken question number 8.1. Here it's saying using definition, show that f of x equal to 3x plus 5 is continuous at x equal to 2. So see the solution. Given fx is equal to 3x plus this, and x is equal to 2. So we have to check the continuity at x equal to 2. Now firstly we will find the functional value at x equal to 2. So f of 2 is 3 into 2 plus 5, so it's coming 11. Okay. Now we will find left hand limit and right hand limit when x approaches to 2. Okay. Next, left hand limit x tends to 2 minus, here we put, and then f of x, then limit this x will change to h. Here we'll write 0, and here minus will put negative, and then f of this 2 minus h. Okay, 2 minus h. So f of 2 minus h will be given by this formula. So we get 3 times, because this is like x for you right now. Okay, so 3 into, in bracket, 2 minus h plus 5. Now first of all, what we should do is we should put h equal to 0, and we should see whether we are getting definite value or not. If we don't get definite value, then we try to do some manipulation. Okay, and then we find the limit. So here right now, if I substitute h equal to 0, then I'm getting a definite value, so that would be the only limit. So here if I put h equal to 0, so I'm getting 3 into 2 plus this, that is coming 11. So my left hand limit came 11. Now I will find my right hand limit. So for this, x tends to 2 plus f of x, limit h tends to 0 plus f of 2 plus. Okay, then limit h tends to, and here f of 2 plus h, this is like x for you. Okay, so this is the definition of the function 3x plus 5. So we will get 3, and here 2 plus h plus 5. Here if you put h equal to 0, then you are getting definite value, so that is the only limit. Okay, so 3 into 2 plus 5, it's coming 11. Clearly your left hand limit is equal to right hand limit, and that is equal to the functional value. Okay, therefore f of x, that is 3x plus 5, is continuous at x equal to 2. Okay, okay, now let us see question number 10. Here we have been given a function fx, which is defined this way. If your x is less than equal to 0 or anything less than 0, then output will be minus x. That means if here I put minus 2, then answer will be minus minus 2. Okay, fx will be equal to x if x is lying between 0 and 1. Then fx will be 2 minus x if x is greater than equal to 1. If I put 2 over here, then the answer will be 2 minus 2, 0. Okay, so this is how this function is defined. So here you can see that function will have different values depending on x, and here this x is depending on what actually? One is 0 and one is 1. Okay, so we have to check continuity on 0 and 1 only, because these are the 2 points, okay, for which this function has been defined this way. Okay, so whenever when we have to check the continuity, okay, we are supposed to consider this point 0 and 1. So here they are saying discuss the continuity of fx at x equal to 0. Okay, so solution for x equal to 0. Firstly, we are checking for x equal to 0. Now see, firstly we will find the functional value for x equal to 0. Okay, so firstly f of 0 will fall in which one? It will fall in this one. Okay, because here is saying x less than equal to 0, your value will be minus x, that means it will be minus 0, that means 0. Okay, so functional value is this. Now we will find left hand limit. So limit x tends to this f of x. Then here you can write h tends to this f of this 0 minus this h. So here this whole thing, okay, 0 minus h will be less than 0. Okay, less than 0. So this will fall under this. So output will be minus this. So here if you put h equal to 0, then you are getting a definite value, that is 0. So you can write 0 over here. Okay, then find right hand limit. Limit x tends to, then limit 0 plus h. This 0 is this one. Okay, now here 0 plus h means it's greater than 0. Okay, so if you have something greater than 0, okay, then it will fall in this one. Okay, answer will be x. Okay, f of x will be x. So here we'll get limit 0 plus h. If you put h equal to 0, you are getting 0, a definite value. Therefore left hand limit is equal to right hand limit equal to f of 0 is coming 0. Okay, no need to write this, or you can write clearly first here, clearly, and then therefore f of x is continuous at x equal to 0. Now we will check its continuity at x equal to 1. Okay, so for x equal to 1, firstly we will find the functional value. Okay, so f of 1 will be, check the function criteria. So if you have x greater than equal to 1, then it will be 2 minus x. So here this will come 2 minus 1, that is 1. Okay, now we will find the left hand limit. So limit x tends to 1 from left hand side, h tends to 0, 1 minus h, limit. Here 1 minus h means less than 1. So for less than 1, okay, for less than 1, this is the one, okay. F of x will be x. So we will get, this whole thing is like x for you, so we'll get 1 minus this. If I put h equal to 0, what I'll get? A definite value 1. And then right hand limit, now this is 1 plus h means greater than 1, okay. So for greater than 1, your function is defined as 2 minus x, okay. So here you'll get 2 minus, this whole thing is like x for you. If you put h equal to 0, you are getting a definite value, that is 2 minus 1. So clearly your left hand limit is equal to right hand limit, that is also equal to the functional value, okay. Therefore f of x is continuous at x equal to 1, okay. So here we proved that this function is continuous at x equal to 0 as well as x equal to 1, okay. Okay, question number 11 will be your homework, okay. This is how function is defined, and you have to check the you have to prove or show that this is continuous at x equal to 1 and x equal to 2, okay. So for x equal to 1, when you are looking for left hand limit, then you have to use this, and when you are looking for the right hand limit, then you have to use this, okay. And for x equal to 2, when you are looking for the left hand limit, you have to use this, and for the right hand limit, you have to use this, okay. So this is hint for you. This is very easy. You have to do same as question number 10, okay. Okay, now let us see question number 13. So here it says find the points of discontinuity of the function, okay. These functions are given to us, and for each function we have to find what is the point of discontinuity, means at what point they are not defined, okay. So solution number 1, f of x is here 1 upon x minus 2. Here when we will say that this function is not defined? If denominator becomes 0, okay. If denominator becomes 0, then we'll say it's not defined. F of x is not defined if x minus 2 is equal to 0 or x is equal to 2. Yes. So if x is equal to 2, in that case your denominator will become 0, so it's not defined. Therefore x equal to 2 is the point of discontinuity, okay. So we will write, therefore x equal to 2 is the point of discontinuity. This was for the first one. Now see second one. Now here this is your fx, okay. So when this will be not defined? If the denominator becomes 0. When denominator will become 0? When x square minus 1 is 0, okay. So f of x is not defined if x square minus 1 is equal to 0. or x square is equal to 1, or x is equal to plus minus 1. Okay, so if you take x equal to minus 1, still you will get denominator 0. If you take 1, again you are getting 0. So for these 2 points, minus 1 and plus 1, this function at these 2 points function is discontinuous. Okay, so therefore at x equal to minus 1 comma 1, fx equal to x upon x square minus 1 is discontinuous, and these 2 points are called points of discontinuity. Okay, third one, function is sec x, which can be written as 1 upon cos x. Now you can easily tell me that when this function will not be defined. Okay, fx is not defined if cos x is equal to 0. That means if denominator is 0, in that case function is not defined. So, or cos x is cos pi by 2. Okay, so you know one standard value for which cos is 0. Now in class 11 we had learned that if we have cos theta is equal to cos alpha, then theta will be 2n pi plus minus alpha, where n belongs to integer. Yes, so in the next step we can write or x is equal to 2n pi plus minus pi by 2, where n belongs to integer. So for all x which are of this type, okay, your function fx is discontinuous. Clear? So here we have got infinite number of points of discontinuity. Okay, therefore x equal to 2n pi plus minus pi by 2, where n belongs to I, is, or r, we can say r, points of discontinuity. Okay, now fourth one is f of x is equal to sin x upon x. Okay, so fx is not defined if x is equal to 0, denominator is 0. Okay, so it has got only one point of discontinuity. Therefore x is equal to 0 is a point of discontinuity. Okay, so this question is also done. Okay, now let us see question number 15. Here it says find the points of discontinuity of the following functions. Okay, first one is this, second one is this. I will do the first one, second one will be your homework. Okay, so solution number 1, fx is equal to x square plus 6x plus 8 upon x square minus 5x plus 6. This function will be discontinuous if this denominator becomes 0. Okay, so fx is not defined if x square minus 5x plus 6 is equal to 0. Yes, this is a quadratic equation. You can factorize it. So here we have 1, here we have plus 6. So 1 into this, we are getting 6. Think of two numbers whose product is 6 and sum is minus 5, minus 3 and minus 2. So x square minus 3x minus 2x plus 6 is equal to 0. X is common, so x minus 3. Okay, so we are getting x minus 2, x equal to 2, x equal to 3. So this quadratic expression, okay, will be 0 if x is if x is 2 or x is 3. So x equal to 2 and 3, these are the points of discontinuity. Okay, at these 2 points this function is not defined, therefore these are the points of discontinuity. Therefore at x equal to 2 comma 3, fx is discontinuous. Okay, and same way you can show this one. Okay, now let us see the next question. Question number 16.1. Here it says if the function f is defined as this, okay, where if x is not equal to 4, then it is defined by x square minus 16 upon x minus 4, and for x equal to 4 it's defined as 10. Okay, then say whether fx is continuous at x equal to 4, okay, or not. If not, why? Okay, so let us see solution. At x equal to 4, f of 4 will be 10. Yes, now we will find its left hand limit and right hand limit. So left hand limit will be given as limit x tends to 4 from left hand side, f of x is equal to limit f of 4 minus h. Here 4 minus h is not exactly 4, so we have to write by this definition. Okay, so this 4 minus h is like x for you, and then you'll get 4 minus h whole square minus 16 upon, here down we'll get 4 minus h minus 4. Limit h tends to this. Here this 4 minus h whole square minus 16. Okay, you can see that this is like a square minus 4 square. So we'll get a square, a minus 4, a plus 4. But here a is what? 4 minus h. Okay, so we'll get this. So let us write this. So 4 minus h minus 4, here 4 minus h plus 4, and down 4 minus h minus 4. So here you can see that 4 minus h minus 4, 4 minus h, 4 minus h minus 4. So these two cancelled. So you are left with limit h tends to this 4 and this 4, 8, and here minus If you substitute h equal to 0, you are getting a definite value, that is 8. Now we will find its right hand limit. Limit h tends to 0 here plus f of 4 plus h. So here 4 plus h is greater than 4. Okay, it's not exactly 4. So we'll get limit h tends to this 4 plus h whole square minus 16 upon 4 plus h minus 4. And same way, okay, this is a square minus b square type. So we will get 4 plus h minus 4, 4 plus h plus 4, 4 plus h minus 4. So these two cancelled, and you are left with limit h tends to this 0, 4 plus 4, 8 plus this. If you put h equal to 0, you are getting a definite value 8. Clearly, left hand limit is equal to right hand limit. Okay, but f of 4 not equal. Yes, therefore f of x is not continuous, okay, at x equal to 4. And this type of discontinuity is called removal discontinuity. If f of 4 had been defined as 8 over here, then this function would have become continuous. Okay, so reason is here is not continuous at x equal 4 because f of 4 is 10, okay, which is not equal to limit x tends to 4 f of x. Okay. Okay, so question number 16.2 will be your homework. Okay, here function is given. This is how it is defined. For x not equal to 1, it's defined like this, and for x equal to 1, it's defined like this. So you have to test the continuity of this function at x equal to 1. Okay, that means you need to show that left hand limit is equal to right hand limit is equal to f of 2. Okay, and here instead of showing left hand limit equal to right hand limit, straight you can find the limit also. Okay, straight you find the limit, and then you can show it equal to f of 2. Okay, because if left hand limit is equal to right hand limit, that means limit exists. Okay, so this will be your homework. Okay, okay children, so this is all for today.